This is a benchmarking on the detection rate or QR code scanner. So what we can see here now on the live in 40 seconds camera is the fixed QR code scanner running live in the backstage Q1728 camera. So this is a 4K camera, which gives us very good resolution to detect high resolution QR codes at long distance. So this code here is 3,200 bytes of data encoded into it. So that is very close to maximum limit of what is supported by QR codes. And we can see that now we can correctly decode it, even though it's far from covering the whole screen. And so these QR codes did support even higher data resolution than we could with a technical scan that with the camera. But it gives you this flexibility to either scan it at a longer distance, like we do here, or to decrease the resolution that the QR code reader is working at, and then you can instead get a higher frame rate. So we can see that right now we are regenerating this code once every second, to 2 seconds for each code. And we have the QR code reader hooked up to our fixed data agent, which is consuming QR codes here and sending them to our InfluxDB database where we are visualizing it in Grafana. So here we can see all the detections live, and we can see the ID number here. So the computer is generating a new code every second, and it's incrementing the ID number by 1. So we can see the 68, 69, 70, 71, 72, 73, 74, 75, and all of them are detected at least once, and some of them are detected twice. Two seconds, 3 seconds, 0.632, 5 seconds, 0.634, 7 seconds, 0.637. So almost exactly 2 seconds for each QR code. So this shows us that we can easily read 3,200 bytes every second. So that's 1,600 bytes, 106 kilobytes per second that we're transferring right now with the QR code reader. And this is in a non-optimal setting, since we're not making use of the whole stream, since it's covering part of it. When mouse changed to a bigger screen, still using 3,200 bytes per QR code, and we have increased the speed of the script to show 10 frames per second. So right now it's a static frame, and definitely just perfect. Now we see the number counting up here with 10 frames per second, and we see that they are continuously detected. We can see that the timestamp is static now. This is because we couldn't generate QR codes fast enough, so we needed to pre-generate all the codes and replay them later. So that is purely a limitation on the computer generating the QR frames, not relating to the QR code decoder. And we should start seeing the frames appearing now in the dashboard here. You can see that we have about 1 or 2 detections of each unique frame. So that means that we are somewhere between 10 and 20 frames per second that we can analyze and detect. And we see that we have all consistent detections, 87, 88, 89, 90, 91, 92, 93, 94. I can't see that we have any missed detections at all. And so that's really good. And again, this is 10 frames per second, 3,200 bytes per QR code, which is essentially the maximum you can get into a QR code. And we see that it still doesn't cover the whole screen, which would make it even more efficient if we could get it a little bit bigger. Now we have reduced the size of the QR code, so now it's just encoding 50 bytes of data into each code, and we have decreased the resolution that the ACAP application is working on. So we're working at a higher frame rate, but we can't detect QR code as far away anymore. And we can see that although the visualizations is a bit strange with these settings, we can see the number here of the QR codes that it detecting. So this QR code is changing 30 times per second. We have the camera set to the 50 frames per second setting. So we're getting close to the frame rate of the camera now. And the QR code is changing 30 times per second. And if we take a look here in the view, we can see the decoded QR codes, the ID numbers of them. So right now we're on ID 5300. The dashboard is lagging behind a little bit, and it takes time for the data to come here to the dashboard and update it. But we can see that we have ID number 5179. And then step W75. So we are missing some detections now. We can't always keep up with the 30 frames per second. But we have 4, 3, 2, 1, 0, 9. And so we can see that it's not many of them that we are missing. It seems to be very rare, actually, that we're relatively rare that we miss any detections. So this is very close to the limit of what it can handle.